So last class we started with stucket faults and what are those introduction to DFT and all those things we already seen, no? So what are the stucket faults and controllability, observability that we have seen. Today we'll discuss about this design. So scan design flow. We'll discuss about scan design flow, design modification, mechanism of testing and task. We'll see these topics. Okay. So, coming to this scan design flow, normally the last class we already seen like when you are doing the design with sequential circuits, there is like a problem with controllability and observability. Okay, so that problem we can eliminate by using this scan design flow. Okay, so this is my original circuit. Normally, this is my original circuit. So you know about the sequential circuit. That means output is having the feedback and it is given to the memory element. Memory element can be a D flip-flop and it is given to the combinational circuit. There will be a feedback for the sequential circuit. Okay. So this one I need to test means what I am doing means here I'm removing this memory element. I'm removing this memory element that is D flip-flop. I'm making this as a scan cell. I'm making this as a scan cell and I'm giving three more inputs to this scan cell that is TM, SE and SI. Okay. TM is nothing but extra primary ports are added to this scan cell. Okay. What are those TM? TM is nothing but test mode. SE is nothing but scan enable and SI is nothing but scan in. Okay. SI is nothing but scan in. Through this scan in only you are giving the test vectors and SO is nothing but scan out. Okay, so these are the inputs you are giving to your memory element. Okay, that is a scan. Okay, so whatever the D flip flop is there, D flip flop that is replaced by another memory element that is cancel. So here D flip flop is there, no? So normally D flip flop we already seen in the digital. So you have D input, Q input, and common clock will be there. Okay, so that this D flip flop clock is there. This D flip flop, whatever the D flip flop is there, you are replacing with S cancel, S cancel. Okay, so this is nothing but S cancel. Okay, scan cells are reconnected to form a shift register. Okay, so that means scan cells are like it is connected like a shift register. In the shift registers, like we already seen like CISO, no? Serial in serial out. Okay, serial in serial out. Okay, so scan cells are how it is connected means it's like a we are connecting like a shift register. Okay, shift register. So when we connect this original circuit with this new circuit, what happens? What is the effect means? We dramatically improve the controllability and observability. Okay, of memory element that is flip flops in the sequential circuits. Okay, last class we already seen there are the issues in the controllability. Controllability means we are getting in the input side. Okay, controllability is nothing but we are getting the uh, in the input side and observability is nothing but you are getting at the output side. Okay, output side. Okay, this is about the scan design flow and design modification. So so like this, there are like three parts you need to make. You need to make the extra primary ports are added for the scan cell, and D flip flop is replaced with the another memory element that is scan cell, and scan cells are connected with the shift register that is scan chain. Scan chain. Okay, and coming to this scan design flow, they are operated in different modes. They are operated in three different modes. What are those modes? Means one is normal mode, next one is shift mode, next one is capture mode. Okay, so normal mode means what? Normal mode means this will function. This is nothing but it's a functional mode which chip works. Okay, functional mode with chip works. That is nothing but normal mode. And so normal for the normal mode, for the TM you need to give 0 and SC is nothing but we already seen, no? SC is nothing but scan enable. Scan enable also you need to give it to 0. Okay. So normal mode means it will works normally. Okay. Shift mode means memory elements. Okay. whatever the memory elements are there, here memory elements are there, no, that is scan cells, those act like a memory cells, act like a shift registers. Okay, mostly they act as a shift register, that is CISO. CISO means serial in, serial out. Okay, and whatever the text vectors are there, those are shifted in response to the shift out. Okay, while applying some clock pulses, that depending on a clock, that will be shifted to the shifted out. Okay, during shift operation, you need to make TM to 0. TM means what? TM means text mode to 0, and select scan enable. So whatever the scan enable is there, that you need to make as 1. This is nothing but shift mode. Okay, and capture mode. What is capture mode? Capture mode is nothing but response of fabricated circuit is captured during testing. Okay, so that means wherever the fault is there, okay, that can be captured. Okay, that response can be captured during the fabrication. Okay, fabricated circuits can be captured. So during capture mode, you need to make a TM to 0 and SE to TM to 1 and SE to 0. SE to 0. Okay, these are the different modes. Okay, one is normal mode. Okay, next is shift mode, and next is capture mode. Okay, and next you see. So scan cell. So scan cell, how we are doing means here. Previously there is a D flip flop, no? Previously there is a D flip flop. This is nothing but my D flip flop. The D flip flop is replaced with there are different kinds of scan cells are used. Most popular is nothing but Muxed-D scan cell. Muxed-D scan cell. So in Muxed-D scan cell, what you are doing means you are removing the inputs, and this is given to 1 mux. Okay, this is given to 1 mux, and one more input is given, that is SI. SI is nothing but scan input. Okay, anyway D is nothing but D input, and SE is nothing but scan enable. Okay, and Q, so Q also work as scan out. You also work as scan out. Okay, so here suppose if you consider SE equal to 0, when SE equal to 0, and this is 2 cross 1 mux. 2 cross 1 mux means so this 0 is connected to the D input. This 0 is connected to the D input. When SE equal to 1, okay, you are giving the scan input. You are giving the scan input to D input. Okay, so based on the scan input, you are getting the scan output that is given to Q. Okay, so extra circuitry is added for the scan cells. Okay, so if you see multiplexer selects two inputs. What are the inputs? These are the two inputs, that D input and scan input. This is D input, and next one is scan input. Okay, so normally, so it will be operated in two modes. No, one is normal mode and capture mode. So normal mode means what? Normal mode or capture mode. So normal mode or capture mode means you need to make SE equal to 0. So SE equal to 0 means what? Whatever the value of D is there, that is latched. Okay, whatever the value of D is there, that is latched. Okay, and next is shift mode. Shift mode means what? You need to make SE equal to 1. The value, whatever the value of SI is there, that will be latched. The value of SI is there, that will be latched. Okay, so basically it will be operated in two modes. One is normal or capture mode, and next one is shift mode. Okay, so if it is normal or capture mode means you need to make SE equal to what? 0. Okay, that is scan enable, and shift mode means you need to make SE equal to 1. Okay, SE equal to 1. Okay, this is scan cells. So what happens? The output pin produce the content of D flip flop. Next state could be D pin or SI pin. Okay, so that means when suppose when SE equal to 0, D is latched. When SE equal to 1, which one is latched? SI is latched. Okay, here output pin is there, no? This output pin produces the content of D. Okay, in the next state, you can get the D pin or you can get the SI pin. Okay, depends on this SE pin. Okay, so when SE pin equal to 1, you are getting SI pin, whatever these pins, SI scan input pins, scan input inputs are there, that is coming to the D flip flop. and when S equal to 0, D input you are getting. Okay, this is scan cells. And if you see the forming a scan cell example, if you take, so this is a series of this one. First, this is the original circuit. Okay, original circuit, and the between the two two combinational circuits, you connected the D flip flop. Okay, so here this is my original circuit. What you need to do, you need to replace this D flip flop. This D flip flop is there, no? So D flip flop with the modified circuit. What is that D input? And you need to add one more that is scan input, and next SE. SE is nothing but enable input. SE enable. Okay, and anyway clock is there. Okay, clock is there, and you are taking here out S out, scan out. Okay, so there is no change made in the previous connection, but D, Q, and clock pins, those are as it is only. But where you are making changes means you are making here SI, SC, and here three flip flops are there. F1, F2, and F3. Okay, and for this flip flop, this is Q, no? So this Q means this S out is acting as a SI for this flip flop. Okay. Similarly, SO is acting as a SI for this flip flop. Okay. So like this, we can make the changes. Okay. And so here what happens? That means these inputs will not change. So these inputs will not change. Only we are changing this circuit only. This circuit only. Okay. So these inputs, whatever the inputs you want, you can give it to this inputs to this these all the combinational circuits. Okay. So the purpose of this scan chain means whatever the sequential circuit is there, that you are converting into combinational circuit by applying some scan inputs and scan outputs and scan enable, and we are making the observability and controllability means easier. Okay, we are converting, when you are converting that sequential circuit into combinational circuit, so we can make that circuit as a combinational. So through the combinational we can give the test vectors. Okay, see that see scan inputs. Okay, so next you see here, SI pin. So if you see the SI pin is nothing but what? First scan cell that is connected to SI port, as I told you. Okay, and QR S not pin, the last, this is nothing but Q, no? This QR S not pin is one cell is connected to SI pin or next of chain. That means here SO is connected to this SI, and this SO is connected to this SI. Again here you are getting SO. You are getting SO. Okay. Last one is last scan is connected to SO port. This is the last SO port. This is nothing but last SO port. Okay. So like this, you can form a scan chain. Okay. Scan chain. So, so here if you see, all SE pins are there, no? All SE pins, all select enable pins are connected to SE port. Okay. Suppose like when SE equal to 0, when SE equal to 0 means what? It is operated in normal mode or capture mode. Normal mode or capture mode. That means normal functionality it will operate. Okay. When SE equal to 1, what happens? It is operated in shift mode. Okay. Shift mode means what? Suppose if you are giving some sequence of data, 111 is there. Okay. So 111 means what? At first clock pulse, 1 will be shifted. Okay, serially it will be shifted. Serial in, serial out. First, it will be loaded with this serial in this. Okay, first clock pulse. So here you will get 1 0 0. At second clock pulse, you will get this will be shifted. So here you will get 1, here you will get 0, and here you will get 1. And at third clock pulse, what happens? This will be 1 here. Here you will get 1 here. Here 1 you will get, and here 1 you will get. Okay, so it is acting as a shift mode. Okay, so that means here it forms a scan chain. So how many scan inputs we give when it is operating in shift mode. So how many number of levels are there? Three levels are there. So I can give 3 bits. Okay, I can give 3 bits. So that means any text vector can be shifted in SI port in how many clock cycles mean n clock cycles. So that means here 3 bits are there. 3 bits that can be shifted in how many clock cycles? 3 clock cycles. Suppose n scan chains are there. So n scan chains can be shifted by using how many clock cycles? N clock cycles. Okay. So any text response can be shifted out to the SO pin for n clock cycles. Okay. So like this we can give the scan design. Okay. Scan design. Suppose after giving 111, you can make other scan chain also 101. Okay, 101. Okay. Suppose like if you consider, so how to find out the fault means suppose here this port is there. This port is somewhere stuck at 0. Okay, stuck at zero means what here so you can get the input as either 1 or 0. Okay, either 1 or 0 like this you can get. Okay, without scan chain it can take exponential number of cycles. So that means when you are not using scan chain, what happens, you need to give sub for 3 inputs, you need to give how many test cases, 2 cube means 8 test cases you need to 8 test cases you need to give. Okay. So with scan chain, how many test cases you are giving? Only 3 test cases you are giving. Okay. So like this, we can decrease the test cases with the scan chain. So, so as I told you, know, with the scan chain, we can convert sequential to combinational circuit for testing. Okay, sequential to combinational circuit. So initially, here what happens initially, there is a sequential circuit. This is nothing but sequential circuit. So by applying this scan chain, I am converting this sequential circuit to combinational circuit. Okay, how you are converting here? If you see, that means I'm converting D flip-flop with these scan chain elements. Okay. So, so pins of flip-flop becomes, so when it is converting from sequential to combinational, whatever the pins we are applying for scan input and scan enable and scan output. Okay. These becomes controllable and observable primary for input and output. So we can give the text cases easily. Okay. Last class we already seen. Suppose NAND gate is there. So NAND gate directly we can give the test cases for this NAND gate. Okay, when the NAND gate is connected between some circuits. Okay, some logic circuit. Okay, here some NAND gate is connected. Okay, it is difficult to give the inputs and outputs. It depends on the on this logic. Okay, so that is nothing but controllability and observability we already seen. Okay, and in this. Qpin can treated as what pseudo primary input PPA. Qpin. So here if you see the Qpin here if you see the Qpin, it can be act as pseudo. Pseudo means what? It can be 0 or 1. Okay. Here also. Okay. 0 or 1. It can be act as 0 or 1. Okay. D pin can act as what? A D pin. So whatever the D input is there, it can be act as pseudo primary output. Okay. So in this so by using this converting sequential circuit to combinational circuit, we can make easy for giving the test cases, scan based test cases, and we can become means we can make controllable and observable, made easy. Okay, by converting sequential circuits to combinational circuits. Okay, and so here, uh, so by using this scan design, okay, by using this scan design, we are effectively transforming the sequential circuit to combinational circuit for testing. Okay, so ease of testing. So testing becomes easy. Okay, so easily we can give the scan testing. Okay, we can easily give the test cases, and we can identify where the faults are there. Okay, where the stucket faults are there, like that, where the faults are there, easily we can find out. Okay, that is the main advantage of this scan design. Okay, scan design. And coming to this ATPG, automatic test pattern generators, problem effectively changes from where to where, sequential to combinational. Okay, so giving the test cases to the sequential circuits is difficult as there is a feedback from the memory element. So we are converting sequential to combinational. So giving the test cases through the ATPG, that is automatic test pattern generation, is easy. It becomes easy. Okay, it becomes effectively the problem effectively changes. That means the problem can be minimized. Okay, and as I told you that shift mode. So shift mode means what? When a C equal to 1, it is operated in shift mode. Suppose 101 is there. So 101 means depends on a clock period, it will be shifted. First 1 0 0 will be there. Second clock pulse 0 1 0 you will get. Third clock pulse you will get 101. Okay. So here so desired test vectors using the ports SI to the scan F1. So here you have three scan cells are there, no? F1, F2, and F3. So through the three scan cells, this will be shifted. Okay. So this is the mechanism of shift mode. So for the shift mode, you need to make SE equal to 1. SE equal to 1. When SE equal to 0, we need to operate in normal mode, or we can operate in capture mode, normal mode or capture mode. Okay, and yeah, so see here, shift mode, this is nothing but shift mode. Okay, so in the shift mode you need to apply the required test vectors at the input port. Okay, suppose during the shift mode, this pin this pin is stuck at 0. Okay, this pin is nothing but stuck at 0. Okay, actually when this pin is stuck at 0, what happens? This pin is stuck at 0. So when you like change the color, it would be, yeah, 1 second. Yeah, here, yeah. So this point is there, no? This point is at stuck at 0. Okay, stuck at 0 means I am giving the input as what? 1 1. Okay, normally I need to get normally I need to get what? 1 only, no? But it is stuck at 0. So that means the output is becoming 0. Okay, this output will be passed through this pin. Again, this output is passed through this pin, and this is passed to SO pin. Okay, SO pin, I'm getting 0. Okay, normally what I'm expecting 1, but I got 0. Okay, so I got 0 means somewhere some fault is there in this design. Okay, so from this I can find where is the uh, fault is there. So here I got like a fault, that stuck at 0 fault is there. Easily I can find out the stuck at 0. Okay, like this I can find out the faults. Okay, so capture mode is nothing but SE equal to 0 for one clock cycle. Okay. If there was a fault, okay. So these are the steps. Okay. How to find out the fault means first you need to operate the circuit with shift mode. Okay. Shift mode means what? These all the test vectors are loaded. Okay. All the test vectors. Suppose all the test vectors are loaded through the shift register. After that, you need to make S equal to 1, S equal to 0 for one clock cycle. Okay, so that is capture mode. So it capture mode means what? If there is a fault for which test vector are applied, scan cells will capture the results of faults and receive the fault output. So in SO pin, you will get the fault output. Okay. Again, what you need to do, you need to make a shift mode. Switch back to the switch mode, that is SE equal to 1, and shift the output capture results to port SO. Result is compared with the expected response. Expected response. That means normally you are expecting 1, but you are getting what? 0. You are getting 0. So you can understand that there is some fault in this circuit. There is some fault in this circuit. Okay, so like this you can find out the false. First you need to operate at shift mode. Okay, next you need to operate at capture mode. Again you need to operate at shift mode. Okay, so capture mode will be operated only one clock cycle only, and again you need to operate at shift mode so that you can find out the faults. Okay. Mm, that is shift mode. um, Simultaneously, we need to apply the test vectors at SI, allows others to scan in the scan chain. Okay. Simultaneously, we can suppose you applied 101. After that, you can apply. So three inputs are there. So from how many test vectors you can apply 0, 0, 0, 0 to 1, 1, 1, 1 you can apply. After that, you can apply 1, 1, 0 or 1, 1, 1 like that. Any number of test vectors are there. You can apply to the scan flow. Okay, scan design. Design preparation. Okay, you need to follow design preparation. Design becomes testable. Okay, you need to follow some guidelines. Okay, so guidelines that follow must be followed during the designing, such that scan design flow used effectively. Suppose you have FSM. Okay, FSM you are using asynchronous reset. Okay, asynchronous reset. So you converted this design into again scan chain. Okay, so whatever this asynchronous reset is there, that may break. Okay, that can break. Okay, so in order to avoid that breaking of that reset, so you need to follow this design preparation. That means uh, whatever the design is there, that should be testable. And scan synthesis. Okay, uh, so you need to do scan configuration. That is during synthesis you need to do the scan configuration and decide the number of scan chains, scan cells. Okay, that you need to decide. And scan replacement also. Okay, during synthesis you need to replace whatever the flip-flops, D flip-flops with the scan cells. Okay, that is scan replacement. And scan reordering and stitching. During the physical design you will get this scan reordering and stitching. Okay, reordering the scan cells based on physical location. Okay, so that routing becomes easier. You are studying about routing, no? In the physical design you are studying about routing. Okay, so during routing it becomes easier. Okay, so these are the scan design flows. And scan design flow cost is there are some limitations are there in the scan design flow related to the cost. Area overhead. Area overhead means what? You are adding some more scan cells. Okay, and routing resources also. Routing resources means you converted this whatever the D flip flop is there. No, you converted the whatever the D flip flop with the extra logic, that is mux. So you added one more mux again. So when s equal to 0, this one more mux complexity means routing. So the connection between here and here. Okay, routing also increased. Okay, scan cells you added. Okay, so this is the area overhead only. Okay, for the scan design flow, there is a area overhead, IO pin cost. So in the STA, you need to calculate the timing path for this one also. Okay, this is also one more disadvantage. Okay, and performance degradation. What are the performance degradation? You are added one more delayed mux, no? So this is you are added one more delayed mux. So when you add the one more delayed mux to this D flip flop, there is a means lowering the performance. The performance may degrade. Okay, and design efforts cost. Okay, for this testing you need to means pay for DFT testing engineers, all those things. But by using this scan test, initially we can find out the stuck at faults and whatever the defects present in this in your design. Okay, so these are the overhead means scan design flow cost related to this uh, cost. Okay, so this is about the scan design flow.